Welcome to POWTS Chat for January 2026. I hope everyone has had an enjoyable holiday and is enjoying their winter so far. As always, we thank you for choosing to spend your time with us today. So today's POWTS Chat is going to be divided into a few sections. Since Matt wrapped up the Wisconsin Landform series last month, we won't be going over that this month, of course. Instead, we're going to focus on two main topics. One, an example of a complex POWTS, what goes into designing, permitting, the questions that should be asked surrounding that, and then some guidance on the annual e-audit for counties. So even if you're not county staff, this will be a good chance to see what the questions counties get asked every year are, et cetera, et cetera. And after that, we're going to open it up to a mini Stump the State. So on the next slide, you'll see a Slido QR code that you can scan and submit your questions. It should work throughout the entire presentation. And I've included that QR code on most of the slides for the presentation. So if you have it pulled up on your phone and then close it out, the QR code should be on most of the slides, so you can pull it up again if you want to ask questions. And then at the end of the session, we'll do our best to answer as many as we can. And if we don't answer all the questions, maybe that'll be really good fodder for POWTS Chat February. So here's that QR code. Like I said, you can scan it and it should pull up a screen on your smartphone device, or you can enter it at the website at Slido under those numbers, and you should be able to enter in your questions. Because we have the free plan, there is a limit to how many characters, so it's 160 characters that you can enter in. So you're going to either have to be concise with your questions, or if you want, you can enter them into the Zoom chat. If you want to be anonymous via the Zoom chat, you can send it directly to me, and I'll do my best to keep track, and we'll answer those questions at the end of the session here. So before we jump into the main presentation, I just wanted to give a quick look at the 2025 plan review numbers, since we do get a lot of questions about them. Full sanitary permit data won't be available until probably February or March, because that is we gather that through the auditing process. But just here's a quick snapshot of how 2024 compared to 2025. So 2025 was the busiest year for DSPS plan review since 2008. With 3,574 plan reviews, which is about 30 more than in 2024. So statistically, that's a very small increase, but it is still an increase. Last January, we started with a really big surge. You can see that in the graph of 2025. But if we had it up for 2026, you'd see that we're off to a much slower start this year in 2026. January just doesn't appear to be as busy. In 2025, reviews stayed steady throughout the summer, and thanks to our plan reviewers, turnaround time stayed at about 2 weeks for most of the year, which is really, really impressive given the number of plans that came in. Looking at ISDs, I thought it would be also interesting to look at that to see that there's been a significant decrease from 2021 to 2025. I picked 2021 because that's the last year before the major component manual update, which included gravity grade reviews as component manual reviews. So most of that drop from 454 to 217 in 2025 is due to that switchover, but that doesn't mean that having fewer ISDs submitted doesn't mean that plans are getting any less complex. Actually, if anything, it means that the ISDs that are coming in are much more complicated with trickier flows, loads, and designs. And it's for that reason, that we actually see an increase in these complex sites, that we're going to be focusing on complex sites this month for POWTS Chat. So what are we going to talk about? Well, in this section of POWTS Chat, I'm going to walk through a hypothetical site. It's totally made up. It's not based on any reality. I made it up. To illustrate the types of questions and considerations that might come up in a more complicated POWTS design and review. We won't actually be designing the system today. Instead, the focus is on what information is needed to design that system correctly and what permitting requirements might be likely to apply. Tomorrow, if you're signed up for that, we're going to be doing 4 hours of design class, but even then, this design example would be too complicated, I think, to go through in that class. Because depending on your approach, it would take a lot more time than we have allotted. So here's a description of our hypothetical site. It's a rural development with several different uses. There's a 6,000 square foot candy store, fun, with 6 employees that also serves drinks like cocoa and coffee and soda or whatever. There's also 3 rental units there. One is vacant, one is occupied by a lawn and snow care company, and one is used by the candy store for production. And there is a 3 bedroom residence that is rented. So in this scenario, we have a residential, a commercial, and an industrial use that's all feeding into a singular dosed system. So it's a complicated site, and but it is something that we actually are seeing more and more of at the state. So that's why I want to talk about it. So here's a look at the hypothetical plot plan. You can see that in this example, they all have their own tanks that feed into a dosed conventional that is failing. So we're working on a replacement system here, and that's why I wanted to use it. So why this example? Well, mixed sites like this are just becoming more common. We see them more and more often across the state. We could swap out this scenario with something like a brewery that also has a restaurant and an Airbnb attached to it. And the underlying concepts would basically be the same. We have an industrial, commercial, and a residential use all on one POWTS. I specifically chose those commercial rental units because they're also becoming increasingly common across the state. Sometimes they're called man caves, business condos, business incubators. They go by a bunch of different names, but the concept is the same. The structures are rented out to businesses or individuals, and there's often really limited control or knowledge of the flows and loads at the time of design. So we want to take that into consideration. So this example lets us walk through many of the considerations that come up during the planning phase of the POWTS. And while these systems must follow the same rules as any other system, the added complexity often means that additional requirements that we wouldn't typically consider, and less common situations they're just more likely to occur. So when we look at a system like this, it's natural to feel unsure about where you should begin. Where do we even start with something like this? But before a system can be designed and submitted, we're not even talking about installation today. But before all of that, there's several key questions that need to be answered. And this isn't the only way to approach a project like this, but for the sake of giving a presentation, I have to come up with a process. So this is just kind of what we're gonna follow here. So first, we need to understand why the system is failing. We don't want to repeat our mistakes. Next, we need to determine what the flows and loads are. Then we have to identify where a replacement system could physically go. In other words, where there is adequate space for a system with those flows and loads. And then after that, we would move into system design, which we're not going to do today. And finally, we would prepare and submit the required permitting and paperwork. So each of these steps is kind of like a puzzle piece that fits together to create the final product. Without any one of them, we don't get a complete picture, but also each piece relies on the others. So we need to figure them all out. So let's begin with the first question. Why did this system fail? Well, to answer that, we need to talk with people who are familiar with the system. This could be the owner, the maintainer, anyone else who has worked on it. I mean, maybe it's you as the plumber. Maybe it's, you speak with the county, they know what's going on, and ask what issues that's been going on in the system. So in this example, the owner has reported that the wastewater is coming out of the vents. Because this is a dose system, to my mind, that immediately points toward a problem with the soil treatment area. When we look at the field in this hypothetical scenario, we see that it's ponded and there's a very well-developed biomap. So now we know kind of what kind of failure we're dealing with, and we can tell that this isn't something that's just easily fixed, like a broken pipe or a failed pump or something like that. But however, to fully diagnose the failure, to really figure out what's going on out there, and to design an appropriate replacement, we still need to determine the flows and loads. We know the system's not working, but we want to figure out exactly why. So to determine the flows for the replacement system, the first step is we need to understand what the original failed system was designed for. So here's just an example, my hypothetical scenario based on previous permits. The designer would have used the flows from the appendix. So, for example, they used for that 3-bedroom, 450 gallons per day, 6 employees, 1 floor drain for each man cave, which is actually pretty generous. It's more than what we would typically see for these kind of designs. In the candy store, 6,000 square feet and 4 employees, coming out to a 1,201.5 gallon per day design. So if you think back to how I described this site earlier, you might already notice that some of the sources of flows are not accounted for in this original design. And that's something that happens a lot. These uses, we design for them and then they grow over time. But if we look at what the flows are now, remember, it's all hypothetical. Since the system was originally installed, the candy shop has added drinks and more staff. Those man caves, despite being one vacant, still have a total of 18 employees and 3 floor drains. So that portion of the flow really is unchanged. And the residence also remains a 3-bedroom home. So it doesn't look like it's changed that much, but we really want to see. And the best way to design a replacement system is to use actual metered flows because they reflect real world usage and show peak days. We want to know if there's a peak day in there. In addition, the appendix in its current form, well, it will probably never address industrial uses because that's the DNR, but it also doesn't adequately or it doesn't accurately capture uses like coffee shops and things like that. Coffee shops are not in the appendix currently, and they're actually pretty difficult to characterize without metered flows. And unlike, waste strength, there's very little that we can do to reduce flow besides, actually reducing the usage. So if the failure is partially flow related, designing with accurate data is critical because we need to know that the actual flows. So in order to obtain this data, we need to do daily meter readings. And meters should be installed in a way that excludes any water not discharging to the POWTS. So we think about like irrigation or something like that. And for design purposes, we should use either the maximum daily flow or the average daily flow multiplied by 1.5. And this is because POWTS are designed with a 50% safety factor for peak days. Systems are not designed and meant to be operated at their design flow every day. That design flow is a safety factor. So if we're operating at it every single day, that's actually not what it's designed for. So here are our meter readings. I made them up. The average daily flow times 1.5 comes out to 1,145.9 gallons per day for all of the uses combined. Everything was metered here. And the peak day flow is 1,857. So just return to our context. The original system was designed for right around 1,200 gallons per day. So which flow would we use to design the replacement system? Under code, the peak daily flow must be used because it is the larger of the two, which means that the replacement system would need to be designed for a minimum of 1,857 gallons per day. Like I said, meter readings can also provide valuable insight into flow patterns. And that information can be used to help determine whether options like flow equalization could be beneficial. So with flow equalization, additional tankage is used to temporarily store large flow events and then dose them out to the soil treatment area over several days. So this can allow for a smaller treatment area than would otherwise be required, based solely on that peak daily flow. And it's especially useful for facilities that see high flows only occasionally, but regularly. So things like churches, where you're seeing most of your flows on Sundays and maybe Wednesdays, wedding barns, sporting venues, things like that. And another important question to consider when reviewing flow data is whether or not the facility anticipates future increases in flow. So, we don't want to design for today when tomorrow is going to be different. So when we look at these meter readings, there's really no clear pattern of peaks. So flow equalization isn't possible. There's not like it spikes on Monday and then there's nothing the rest of the week. So flow equalization is not going to help us out here. And that's just something you want to keep in your toolbox and remember. We also want to note that one of those man caves is currently vacant. So if we estimate its flow during the peak day from the other unit, that would add an additional 191 gallons per day. But this is really tricky because we don't know what the next tenant is going to be. Is the next tenant going to be a guy who just stores his car there and doesn't use any water? Or is it going to be something that has 20 employees? We really don't know. And that's why these uses are so tricky. Anyway, if we use 191 and we add it all together, the design flow totals up to 2,048 gallons per day. So it's easy to see why that original system isn't working in this case. The flows are higher than it was designed for. But flows are just, one piece of the puzzle. Another critical piece is the waste strength or loads. So if we look back at the original permit, all those uses were domestic strength, and the system was designed for domestic strength wastewater. That's what it was, intended for. But if we look at the current wastewater strength, it's a lot more mixed. So the house and two of the man caves remain domestic strength. I mean, one is vacant, but one is domestic. Um, but that candy manufacturing process that was added introduces an industrial strength waste stream, which could also be high strength because it's food related. I don't really know, I don't know what they're doing in there, I guess. Even though I made up the scenario, I still don't know what they're doing in there. But it's probably high strength because it's high sugar, high fat, high whatever. And the candy store also sells drinks that are made on site, which adds an additional high strength waste stream to this. Coffee shops, there's a lot of milk products, high BOD, high TSS, high FOGs sometimes, depending on what they're doing there. So it's high strength. So without testing the existing system, the replacement system would need to be designed to handle that high strength wastewater. Um, So maybe the next step would be to test the wastewater. But what does the code say specifically about calculating out the wastewater strength? Well, it first specifies the strength parameters that effluent must meet before reaching the soil treatment area, and it also provides the sampling requirements. So the samples must reflect the average that they, sorry, um, they must be taken over 30 consecutive days with at least 6 measurements occurring on 6 separate days, and then it's the average of those samples. And that tells you whether or not something is domestic strength or high strength. So here are hypothetical lab samples of, samples that were pulled out of that dose tank. If we remember back to the example, there was a single dose tank feeding that field. So is this domestic strength? If we look at it, the BOD is 219.5, TSS 144 or 145, FOG 19. Is it domestic strength? Well, technically, yes, because it is below, on average, below the high strength parameters, and it could be sent to the field. However, given that the existing system is failed, it's probably wise, although not necessarily required, to design for more than just domestic strength. Maybe you're adding in some extra treatment in the treatment train, like additional tank volume or additional field space, or maybe some form of pre-treatment, because we know that this is, well, it's not high strength. It's just about as close as it can possibly get. So another part of the loads is the industrial component, which requires DNR concurrence for mixed wastewater. And what do we do about that? Well, the DNR is the one that would issue a concurrence letter for it, but their review requires much of the same information as DSPS, in addition to some, they want some additional details. So additional details that the DNR might require for their concurrence process would be the process that's producing the wastewater. And they typically also want to know the chemicals that are used for cleaning. They want to know more what's going on internally to create that industrial wastewater stream. And they also need to know how the solid residuals are managed. That'll be a part of the concurrence letter. So those are just things to consider when you're working on these kind of designs, questions to ask about the industrial flows. So in our candy making example, there probably wouldn't be that much industrial wastewater actually produced. And if we look back at the flow chart in my example, there wasn't that much water. Candy making is a pretty dry process. But if this were a brewery, for example, the industrial flows might be a lot more complex and there might be a lot more flow. And so the industrial portion of the wastewater flow might have a much bigger impact on the system design because it is just by proportion, a larger portion of the POWTS design. Another thing to consider is we also need to verify that they aren't doing any vehicle maintenance in the other buildings. Well, maybe they can do vehicle maintenance, but that vehicle maintenance is not, wastewater is not entering into the system. We have that snow and lawn care building. Make sure that any vehicle maintenance wastewater isn't entering into the system. So now we can kind of start to put things together. We know the flows, we know the loads, we think we understand the system issues. And from here, maybe we can move on to finding a site and then designing and submitting the system, the things that we kind of consider as the system design. So if we return to our site plan, there are several things that we need to consider. When we're looking at siting a system, we want to know, what did the old soil tests show? Old soil tests aren't always perfect, but they can help you out. We want to know if the existing tanks and piping can be reused. These are things that you'd want to look at while on site. We want to know, is a grease interceptor required anywhere? We want to remember that generally, well, we want to know that if greasy waste is being created, then a grease interceptor is required. And if folks have questions about grease interceptors, I'm going to defer you to our general plumbing staff for that decision and guidance on that, as that is really in 382, which is under general plumbing. We also want to look at if there is any practical reason to split into multiple systems. Would there be a reason to do that here? And then finally, after we know all these things, we want to take a look at where can that soil treatment system, where can the new field go? Where can it be located? So here's just a few specifics on our hypothetical site. So let's pretend this is located in the Glacial Lake, Wisconsin basin. So recall what you learned from Matt last month. And we know that maybe the soils are probably pretty decent here. So we're not super scared of them. It's not, the Lake Superior clay basin. It's sandy soils. The previous soil test showed 0.7 soils with no limiting factor. It's just depth of excavation. So from this information, because we can maybe reasonably assume, we can start to think about what might be required even before going out on site. So we can kind of get a ballpark of how much area is going to be needed and where the soil test area kind of should be located. And then based on what we know about the plot plan, because these are all things that we want to think about before we even get on site, is whether pre-treatment would make sense before sending flows out to the field. Do we have such a limited area that we need to do it, or would it make sense to do it anyway? So here's just a really rough calculation. With 0.7 soils and rounding up to 2050 gallons per day, we're going to need 2,929 square feet of soil treatment area. So maybe 3,000 square feet be a good roundup there. And there are multiple areas on the property that could work. So which one makes the most sense? Well, from just a cost and practicality perspective, the option that requires the fewest moving pieces is probably the best option. Not always, but it's a good place to start. So what about the existing field area? So here's the existing field area. Possibly we could go underneath it. Maybe that could work. There's 4,100 square feet there, kind of just estimating. And since it's already going to be an ISD because it is a mixed POWTS, maybe it makes sense to remove the old system and replace it with a sand-based sand blanket system or something like that. It's already an ISD, so maybe we could put it there. We also want to consider future land use when trying to figure these things out. So what if the owner wants to add an additional rental shed? So this is to the north of that existing one. Would that be a good place for a new system? There's enough area there, but what if the owner wants to put a new shed there? Or what about, in the area just north of the candy store? What if they want to add a drive-through there or something like that? Just things to consider, and things to discuss with the property owner. And finally, we want to think about, what if the new soil test requires an at or above grade system? In that case, maybe it makes more sense to separate the systems as the entire system might not fit in one location. Just things to consider and to build in contingencies so that you're not kind of left stranded when you're out there. So as I mentioned, we won't be designing the system today, but if we were, here are just several considerations you would want to address. So is dosing required? Yes, dosing is required since the flows are above 1,500 gallons per day. Is pre-treatment required? Not strictly, since the flows are domestic strength. Well, it would also depend on if the DNR is requiring some for their industrial component, but we might choose to include it. Is there anything else about this that is an ISD, that an ISD would be required for other than that mixed waste? Because we would want to address that in the design. Is pressure distribution required? Are additional tanks needed? That's something that you want to plan into the system. I'd say likely because the flows have increased. I didn't set any tank sizes in my example, but more than likely, especially with that change to the candy store. Can all the setbacks be met? Do we need variances too? And if there are any other site-specific considerations that you can think of, the questions are endless, but we want to think about them as we work through the process. So now on to the paperwork. What paperwork is required? So for submission, we need to include all of the relevant information that would support the design. So this includes, but is not limited to, a complete and accurate soil test. That's the basis of our system, the beginning of our system. We can't design without a soil test if we're doing a field. We want a complete system design. We want an ISD justification statement, so that explains what the ISD is and how it is addressed in the system. We want a detailed project description, which I have more information on my next slide. We want the actual lab results, so not just that average that I showed on those early slides. We want the actual lab results that say what lab it was in, what the results were, all that, the actual results from the lab. We want the meter readings. We want a management plan, of course, as is always required. We want the DNR concurrence letter. DSPS by code cannot give approval for a plan without DNR concurrence. And if we're going to have a grease interceptor, we want an agreement for the greasy waste management. And any other additional supporting information. Maybe we have some health department licensing that says what they can and can't do. Maybe we have a county on-site report. Maybe we have some plumbing plan reviews that show what the interior plumbing looks like. Anything that could be used to support that design. And the more documentation that you provide that support the design and reasonably make sense. We're not asking for every single thing, but the more you can provide, the stronger and more defensible the plan will be. So I just want you to keep in mind that the plan reviewers can only review what they are presented, and nothing should really be assumed, I guess, because if you don't tell someone, they can't know. So here's my final slide on this, and it's about the detailed project description, which is a requirement that was added to the component manuals. We don't have a super strict definition on it because it really depends on what the project is, how detailed it needs to be. But even though it's being submitted as an ISD, a project description is still mandatory, even though it's a component manual requirement, it's still required even if it's an ISD. But usually they're not super long. Most project descriptions are not really long, but in this case, where we have so many different flows, so many different loads and different uses, the project description might actually end up being a couple of paragraphs. So you want to take some time and draw something up that explains what's going on. So it needs to include the nature of the flows and loads and how they were calculated, a detailed description of all the contributors, what is contributing to that wastewater. And we also want to include any, anticipated future expansion that was included in that design so that it kind of makes sense. So this project description ensures that the reviewers kind of understand the rationale behind your design decisions. And it's also a place where if in the future someone is looking at this plan, it's like abridged notes. Instead of having to go through the 30, 40 pages that might be a complex commercial plan, here's just an area that we can get a synopsis of what's going on there. And it's really, really helpful. And I would really encourage people to spend some time on the project description because it really, really helps. So with that, I am going to turn the microphone over to Matt for some guidance on the e-audit.
All right. So we're going to go through some of the e-audit, what the form is. This is what we send out to the counties every year so they can report back to us some of the activities that they do. So um, this is actually on an Excel spreadsheet form. We're thinking about changing it next year. We'll have to see if we can do it through our databases that we have. But the reason we do it through an Excel spreadsheet is that sort of off the screen here, if there's an answer for yes or no, it puts a number, and then we can cut paste those into a master spreadsheet, and it tabulates our results for us. Little archaic the way we've done it, but in 2000 when this was created, it worked pretty good back then. So we've sort of been sticking with it for lack of a better option right now. But there's some just general questions that we go through, and these are ones that, this is sort of a self-certification. This is also what we do in the field is when we go to the counties and do an in-office audit every other year is typically what we try to do of the county. We verify these questions, but this is sort of self-reporting. So like here, the first question is, are soil and site evaluation reports for proposed POWTS reviewed within 6 months of receipt? So if you notice that, like when you send in the CST sends in a report, that there will be in the upper right corner, there's a spot for somebody to sign off on that. The county person will, put their name and a date when they reviewed it. So it's not necessarily that they reviewed it out in the field or that they agree with everything on the form. It's that they reviewed it, make sure it's complete, make sure it makes sense. That, as Katie said, you're in the Central Sands area and somebody reports red clay, you're going to go, that doesn't sound right. Maybe I should do an on-site. So it just shows that, if the soil test came in on June 1st, they would have then 6 months in order to review that. It has to be reviewed within that 6 month time period. Are they signing off? Things like that. And then each of these questions we do put in the statutory and the administrative code sections, what it refers to, why they need to do that. It's has the references in. So some of this is just, like this. Did they review them? Are they reporting it on the form? Are they doing the filing of this? It goes down, if they can't, if they're not verifying them, why they didn't get to them, things like that. So the important thing for the counties, I know those of you that are not counties, it's maybe has just some, not as much impact for you, but it's sort of interesting to know what they do. But for the counties, just make sure, I know a lot of these questions are the same ones we've had every year. Make sure that you read through. Sometimes we do have some minor revisions in here. Make sure you're reading through each of the questions and filling them out. There are a couple questions that we historically have a number of errors or issues here. The first one I like to point out is question 8. Are all private systems inspected? So now not only do we have a yes, no answer, but we also have a number of systems inspected, number of systems installed. And the reason that we need those numbers filled in there is we need to be able to ascertain, is the county doing the inspection? And this is just a one required inspection prior to backfilling. Um, and so we just need to know. So if there were 150 total systems installed in the county, how many systems did you get to? And it's not necessarily an issue if you didn't get to all of them. Obviously, if there's 150 installed and you did 3, we would probably say that's an issue. You're not doing the inspections as required. However, if you did 150 systems installed and you missed 3 and you were at 147, just because whatever you had a person that retired and you didn't have a person hired in soon enough, or you're a one-man show in the county and you had the COVID or flu and you're out for a week and you missed a couple, that would be a reason to put an explanation in there, and that's fine. We just want to, be able to identify how many are being inspected or not. So scroll down here is just more questions about, how enforcement is done, who's doing it. Is it the county? Is it the health department? Something like that. So we do have some spots in here where they can enter some text for us. This one here is talks about governmental unit ordinance. What's your ordinance? Have you had revisions? So there's a requirement for the state to take a look at it. And just has that been done? So if you've been updating it, you can also just send a copy of the ordinance in here. That's very helpful for us. And then Section 3, sanitary permit data. This is one that gives people a lot of issues here. So the first thing is line A is the gross number of sanitary permits issued by the department. So that's total number of sanitary permit numbers. On quarterly submittal that comes into us, the counties are required at least every quarter. Some do it monthly, but they're supposed to send to us a listing of what permits they issued, and then they're supposed to send to the state a $100 fee for every sanitary permit issued. So the gross number of permits, A, is the total number of sanitary permit numbers issued. So let's say you issued 1 through 200. But there is no fee required, and this is listed on the form that you send in quarterly. There's no fee required for transfers, revisions, voids, or renewals. So if you issued, let's say, permits 1 through 200, but you really only had 180 permits issued because the other 20 were transfers, revisions, or renewals. You would put that on your quarterly form. You'd say, hey, I issued permits 1 through 50 this quarter, but permit 3 was a transfer, permit, 5 was a revision. You can list those numbers in there and say we only had a net of 45 that we have to pay the fees for. So that's where, so you should be issuing a new permit number even for transfers, revisions, or voids or renewals. And if any of those, so that's why it says minus for C, D, E, and F. So if you issued a gross number 200, but you only had basically a net of 180 because the others are transfers, revisions, or renewals, then you would write in G the 180. So range of permit numbers may be 1 through 200, but again, there's only a net of 180. So this is another one that gets messed up very often. Either the counties are not issuing new permit numbers for transfers or revisions or renewals, or I don't know. There's always always issues in here. So if you have questions, give me a call. I'll walk you through it. And then number 2 down there is the number of new systems, replacement systems. Again, this is a question that gets asked of us. And just for some background, not only is this audit information collated for data such as this, but also to ascertain whether counties are complying. But we report this data to a lot of private people will ask for it, manufacturers, other environmental groups, things like that. We also have to give a biennial report to legislature on the state of the POWTS program. That's required. So this data does get shared. It is important data. We have to make sure that it's accurate. Local plan review, this one in here also has some questions. This is plan review. This is not permits. Permits was the previous section. So when the counties report this, this is the number of plans that you reviewed at the county level. So it's what you have agent status for. So if you only have agent status for conventional 1 and 2 family dwellings and holding tanks, you should not be reporting mounds and at-grades. If you issued that 200 permits total, 180 net, and 30 of them were mounds, but you don't have agent status for mounds, don't report them here. This is just what you at the county are doing for plan review. So make sure that whatever is agent status. So even at grades, if you have, let's say you did 10 at grades, but there were 2 others in there that were reviewed at the state level, you only put the number 10 in there, not the 12, because you only reviewed 10 plans, not 12 of them. So just make sure that that comes in there, and then number of your employees and what your credentials are, and then there's a section for comments at the end. But anyway, just wanted to highlight a few of those things on that. Make sure you're reading the questions. Make sure you understand what the question is asking. If you don't, give me a call, and I'll help you through that process. And then for everybody, like as Katie said, once we get all this collated, we have 19 counties that have reported so far, due date of February 1st. So the counties listening, if you haven't reported yet, you've got a couple weeks in here yet. But we like to try and get them in by February 1st. I've already got people asking, what's the data? And I go, well, the year just ended. I haven't collected it yet. We got to have time for everybody to close out their books and get that information to us. So hopefully we'll have some data, later on in February if we can get everybody to report. But we're at 19 out of the 71 counties so far. So anyway, that's all I have on audits.
Awesome. Thank you, Matt. All right. So let me forward the slide. So the next thing that we're going to do is we are going to go through, we're doing some Stump the State. So I did have the opportunity for people to send, and I don't know if anyone has submitted a question. It's not popped up because test was me when I tested it earlier today. So if you want to submit a question in the Q&A, you can scan that QR code in the upper corner there, and it should take you to a web application. It works really well from your smartphone, to be able to submit a question. And if it doesn't work, we might have to
Yeah.
rely on the chat here.
Yeah. If you have submitted a question, let us know in chat
Yeah.
because then we know that it's not working at least.
Yeah. But we did, so while that goes through, we did get a question in email this morning, so I wanted to go through this briefly and answer a few questions. So the question that we got in email was, what type of approval, if any, is needed for a garage floor drain installed for residential use, like a detached or an attached garage? Does the non-domestic waste generated need to be directed into the POWTS, or can it be daylighted? If it needs to be directed into a POWTS, does it need DNR, DSPS approval or letter of concurrence, or is it just handled through the DNR for non-domestic waste? So it's a long question, and the answer is actually probably even longer because there's a lot of things to unpick here, and maybe garage floor drains would be just a good topic for POWTS chat one day. So I wanted to go through a few things here, and these come from 382. So really, it's the realm of general plumbing. So I'm overstepping my bounds here, but hopefully no one in general plumbing gets too mad. So there are some code requirements in 382 for floor drains for garages for 1 and 2 family dwellings. So they should be provided with a sediment basket, et cetera, et cetera. That's in 382. As I understand it, for private dwellings, like a DSPS plan review would not be required. Maybe municipal plan review would be. It would depend upon, you know, the municipality and what they require for plumbing inspections and things like and permitting and things like that. But I wanted to talk a little bit about also the table in 382. So table 38238-1 is the allowable discharge points for fixtures or specific uses. So this is the table in 382 that tells you where specific uses or fixtures are allowed to discharge. So if we look here at, item number 9, so that's 1 or 2 family garage floor area, and noting that code reference there. So that code reference is for this code section here. It tells us that it can discharge to a POWTS when that POWTS is designed for that wastewater. It can go to a municipal sanitary sewer. It can go to the ground surface unless it is prohibited by the municipality and when no nuisance is created, and to a combined sanitary storm sewer. And this is for, garage floor areas like for drippings and things like that, not for pouring your oil down the drain. That's totally different. When we're talking about pouring oil down the drain or, I don't know, whatever people do in their garages, and it's an industrial waters have different allowable discharge points. So if the wastewater is industrial, it can go to a POWTS if it's designed for it. And we'll talk about that on the next slide here. It can go to the municipal sanitary sewer or the combined if it's allowed. But you notice that the ground surface is not an allowable discharge point for industrial wastewater. But because industrial wastewater is regulated by the DNR, they have some additional language on that, for these motorized vehicle storage. And they're talking largely about public facilities and things like that. But, kind of maybe, I mean, you'd want to talk to the DNR and General Plumbing about it more specifically. DSPS POWTS is probably, we're the low man on the totem pole here. But if the floor drain is receiving only snow melt or rainwater drippage, then generally, per the DNR, this is per their website, it can be connected to an industrial or mixed wastewater subsurface disposal system. But if that wastewater discharge from floor drains contains other materials, then it generally cannot be. So, like salt, excessive solids, things like that. And if there's any potential for future vehicle maintenance to occur in the facility, then the DNR probably is not going to grant approval for subsurface disposal
Yeah,
because
we had a
there are
question in the
specific rules about not putting oil down the drain.
yeah, we
So,
had a question in the chat, and I think this just answers it, is that if it's just snow melt or rainwater drippings, then it could possibly go into a system. But if there's any kind of maintenance that's being performed there, then they would not be allowed to go into a subsurface system of POWTS.
yeah, it's really about the contaminants that are going into it. So, all right. Okay, well, all right. So it looks like we did get some questions, so that's good to know that it's working. So here are some questions, and I realize that people had to be concise because of our character limit, but here we go. Is DSPS still considering amending table SPS 383, table A 38343-1 appendix to account for campgrounds, tourist rooming houses, and other design flow examples? Matt, do you want to possibly?
Yes. And next question. No, that's honestly yes. We've done some work on that. I do not know where it's at right now. There was some talk about trying to do something. Right now, General Plumbing has the whole group of codes open, and there was some talk about possibly trying to get it inserted while they were looking at it. It did not look like that went through. The appendix is can be updated without going through code, but we don't want to do that. We want to make sure that it gets vetted and that there's time for public input for it. So I do not know where it's at. I believe that now we're going to try to get it into a TAC meeting, a technical advisory committee meeting, and try and get it through them and let them comment on it. But right now, yeah, we're still considering it. We have some background information done and some proposals, and that's where we're at. Once we know more, we will share it as soon as we know more. But right now, it's sort of we're sort of holding tight at the moment.
All right. So another question here. Is a letter required from a plumber if reusing an old tank or other state-approved product from a previous POWTS for use in a replacement POWTS? Matt, do you want to answer this one too? It's kind of going to be kind of county specific, I guess. So I guess I'll answer it. So sometimes
Oh,
counties
sorry, I
will.
was
Oh,
muted.
okay.
I was talking, but I was muted. But yeah, we would need to have something from them if we're using an old tank. Basically, we have to have it inspected to make sure that it's still sound and watertight. So, not that we can't reuse an old tank. How much work needs to go into it depends on what we know about it. So, if it was a tank installed, even 10, 15 years ago, we have product approvals, we know about it, and we know the size and everything, we still need somebody to look at to make sure that it's still sound and watertight. If it's something older, we may need more information. If it was old, hand poured tank from the 80s and we don't have a lot of information on it, we'd still need somebody to take a look at it, make sure it's structurally sound, determine the size, et cetera, et cetera. So sort of depends on what we have, but yes, we would need to have not necessarily a letter, but somebody sign off to say they inspected or looked at it.
Yeah, and some counties have specific forms that they want used for this because it outlines the information that they want to see. Okay, so we have a question that came up in the chat. How much evaporation can realistically take place in a tank that is not in use over a 2-year time frame before putting up a red flag? And I would say to this, each system is unique. And so depending on how the system is outlined, I personally couldn't say how much evaporation could realistically take place. Some systems have way more venting and air movement than you would think would be normal, so there might be more evaporation. So I don't know, Matt, do you
Yeah,
have?
it's going to depend a lot. D depending on, how deep the tank is buried, like you said, how much venting they have there, the temperature of the soils, when it's used compared to when it's not used. There's a lot of variability in there, but again, if you had a 3 bedroom home connected and even with one person there, I'd still expect that, their holding tank's going to fill. I assume this is a holding tank question. Their tank is going to fill up, and it's not all going to evaporate out faster than it's going to be filled. Um, so I think there's, or if it's you know, an anaerobic tank, I would venture to say they're still going to have some liquid in it. And if there's not, then I would be asking some questions and looking at that system more carefully to figure out what's going on. Maybe it is, but I would still be concerned.
All right. Can a drain field be plowed by using a skid steer with forks? Is this an acceptable practice? So here's what I would say, and I guess we'll get Matt's opinion afterward. If you have a question about plowing practices and the outcome of the plowing practices, sending a picture of what the plow looks like or having someone else on site to take a look at it is going to be the best way to know, because there's a lot of different ways to plow a site. And in the end, if the outcome is acceptable, that is what we care about. There, you could plow with a shovel if you wanted. If it turns out right, then it would be, acceptable. Matt?
Yeah, this is a question in my district, and it's we're dealing right now with what are we calling a plowing, and I know we're looking at doing some training for the county um, inspector training here this winter, coming up with some better language on what exactly plowing is. We used to say moldboard or chisel plow. We realized that sites, especially with a lot of roots or whatever, you can't get an actual farm implement tractor and pull behind a plow. It's just not workable. So the goal is to cut and turn the soil. A skid steer with forks to flat blades, I don't think really do. I mean, you're disturbing the soil, but you're really not cutting and turning, and that's what the goal is to break up that sod, break up the surface matter, cut and turn. You have big flat forks, they're going to be smearing more than they're turning. But with that being said, under some circumstances, if it's really sandy or something, you probably could get by with it. It's sort of messy. My bigger concern is that by doing that, you're going to be driving back and forth over it, and that's what we want to minimize. Most of the alternative plowing that we've seen are usually done with a bucket or something, and they're pulling an implement across it, and they're not actually driving on the site. So for the most part, I'd probably say no.
All right. The next question regarding linear loading rate. So if the linear loading rate is less than 3 gallons per day per square foot of soil in the first 12 inches, the linear loading rate is limited to 4.5 gallons per day per square foot. Does this apply to both modeling within 12 inches, but still has A+4 and bedrock? So the linear loading rate restriction applies to the soil application rate that is designated by code. So if the soil has a less than 3 linear loading,
Editor's note, I should have said less than or equal to 0.3.
so let's say it's a massive silty clay loam, and we are at a zero loading rate, then that 4.5 linear loading rate restriction is in place if it is within 12 inches of the infiltrative surface. Bedrock does not have a a soil application rate, so technically that doesn't apply. Modeling doesn't technically change the linear loading rate because it doesn't technically change the soil application rate. However, the code does say that if there is something there that soil horizon that is going to affect the infiltration of the wastewater and things like that, it should be taken into consideration.
Yeah,
So,
you could have soil that's all 0.7, but you have redox within 12 inches. It's still a 0.7 loading rate. So
yeah,
it does not apply here to the less than a 0.3 because there's, you know, there's no, it's not less than the 0.3 loading rate.
yeah. And I think that there we have a question here about glade horizons as well, and I hopefully that covers that. Okay, so we have another question here. How is bathroom waste dealt with in a milk house? Who permits the waste for both? If it is all DNR permitted, how would we know for the maintenance program? So the domestic waste is domestic waste, the industrial waste is industrial waste. Milk houses, if they are combined, it would be mixed, both review. If it is strictly the domestic component, then it would just be strictly domestic, or if it's just strictly
But
the
I'll tell you
industrial
right now,
component.
it's not going to go into a POWTS other than a holding tank.
Yeah,
Milk house waste, if we're talking BOD, milk house waste is about 800,000.
yes, very,
So
very strong.
yeah, we're not doing it.
Yep. All right, so it is now 10 o'clock. Oh, and it looks like we have one more question. So let's just do it. So, does the state need to approve a dump station holding tank application before the county can issue a permit? Well, the dump station itself would require DSPS general plumbing review. And then the whole tank would be, I suppose it could be a county review, couldn't it, Matt? Because it's
Yeah,
not, it's
if it's a
just,
holding tank, it's a holding tank.
yeah.
It depends what so if it's under the sizing there that the counties have jurisdiction for, then that would be issued for that. But the dump station above it is general plumbing, but the holding tank, it's just whatever you'd have holding tank approval for. So if it meets the sizing limitations, gallons per day flow, you'd be able to issue the permit for that. We also do have one above it on Glade Horizons, if you want to catch that one quick here before we
Oh, yeah. Okay.
end.
Glade Horizons, how does that affect the limitation and the loading rate considerations? Like we had said, if it's not necessary, I mean, obviously it's a limiting factor, it's Glade, but loading rate and things like that, you want, depending on the nature of the soil itself, you want to take it into consideration, but it does not
Yeah,
necessarily change
it'd
things.
be the same as redox, or Glade is basically a form of redox, so you consider it the same as that. So limitation, depending on what we're looking at, is it the 0.3 loading rate that it doesn't affect because it's based on the texture and the structure of the soil. Loading rate considerations, it's the same as encountering static water table or redox. Again, you want to take that into account when you're designing as a limiting factor to what kind of system you're going to have, but there would be no special considerations. It's just considered the same as a redox limitation.
All right. So with that, I think that is everyone's questions, and I see people are entering their names and credentials into the chat. So thank you for that. Thank you for joining us here today.